Okay, this is the assignment number 5 overview, the one that is on the normalization activities, which is the last assignment for this course. And everybody who showed up, actually, who did yesterday's, you don't even have to do this one if you don't want to. You could pick one of the 5 if you're doing your database stuff, which means, so this is the necessary evil. So everybody shows up the first weekend, and then they show up the last weekend because they have to. So most people skip this weekend, which is actually kind of ironic because I don't know how many people we have in the class because I think most people are here this weekend. So if you actually showed up the second weekend, which is the optional one, a lot of people skip, then what ends up happening is you miss out on the activity of being able to replace one of your 5 assignments with the in-class assignment because it has to be done this weekend. So it's your reward for showing up a second weekend. I figured it was a nice incentive system. So anyway, it was just yesterday's activity that gives you that. But most people, that's easier than today's activity. And today's activity I'll discuss after lunch. But long story short, if you don't want to do this one, you don't have to do this one. I would say this one's not as hard as the other one on entity relationship diagramming. That's the one I'd probably skip, and I'd probably do this one instead. But what is this one? You're first going to analyze a table design. So you're going to normalize the table below to achieve a design where all tables are in third normal form. We're not going to do B, C, and F. You're going to create a functional dependency description for each one of the new tables that you created. And you're going to create a simple table description for the final tables. So let me talk about what I mean by that. So the functional dependency descriptions look like this. Column A depends on column B, C, and D, which means column A is the primary key. Or column A and D depend on column C's C and F. So that's a functional dependency. So this is as if you were to write them out with circles and lines connecting them together for functional. It actually turns into a function. This is a stripped down functional dependency diagram actually. And I talked about dependency diagrams and I talked about entity relationship diagrams in week number 1, so it's about a month ago by now, but yeah, or so. But don't worry about that. You can use this format. Most of you will probably be using this format up here, but this one here is a little bit more complicated. You can switch the order around, is what this means. You can actually have A, B, and C, and D all depend on F. Anyway, but you're just showing with the arrows that one depends on the other. Note the simple table description should look like this. Table A has column A, B, C, and D in it. And I underlined A to say that that's a primary key. And then I have a foreign key, and the foreign key is column E, and it refers to table D. And then we don't have to say where, but it's in D. It's column E, it's in table D. That's all you have to do for the description part. So you're writing one of these, and you're writing one of these for each one of your tables. And you're just showing the dependencies, and you're showing the descriptions. So give the table name and a list of columns that compose the table. Designate the primary key by underline a column name, that's the primary key. Designate the foreign key by listing them beneath the table description as demonstrated above. People use this table description format because it's very closely tied to the SQL queries that you use to create the tables. And a lot of people put the foreign key and the primary key designations underneath at the end of the table creation command. So this is where that practice sort of comes from. And if you're used to writing the descriptions this way, then you're going to write your table creation commands this way too. This is not an SQL query command. This is a description format that you use to describe. Wherever you work, they're going to tell you to do it their own way using their own description format. This is the dependency, very commonly used dependencies, a very commonly used description format. Don't worry about the syntax if you can't get it to look exactly like this, but you should be able to write them like this. You can write any table like this actually. Because you don't have more than one primary key, and you shouldn't, well, you might have more than four. If you have more than one foreign key, then you put underneath it foreign key, column E, foreign key, column A, foreign key, column D. Refers to table D, refers to table E, refers to table F, or maybe they all refer to table D. Who cares? This is not word wrap, it's different lines. Line number 1, line number 2, line number 3, line number 4. It just breaks it all out. And here's your problem description. So you're given the following database. You're going to normalize the database to be a third normal form database, you're going to create the functional dependency descriptions for all the tables, and you're going to create the simple table descriptions. So you're doing these two items above for the resulting list of tables that you're going to get. Here's your table. You have a customer order table. The customer order has a customer ID, which is underlined here. Customer first name, last name, middle initial, street address, city, state, customer state code, customer state name, red flag, postal code, country code. All this stuff is listed for each customer. And this is all in one table called the customer order table. Hint, hint, hint. Some of the stuff doesn't belong in this table. Some of the stuff belongs in another table with maybe, location information or something. You're going to pull it out. Oops. If you go down to the bottom, you see it's all in one table. You only have one table. So it's just like the example in the last lecture I gave you. So you're going to take customer order table and you're going to pull it out so that you have customer ID. And then down here on the bottom you have order ID. This is all in the same table. So you're probably going to have an order table that you're going to pull out of this table. And then you're going to have, is there anything else down here? No, there's nothing else down here. You can have a product table too. Yeah. You can have 4 or 5 different tables coming out of this actually. Depends on how you want to break it down. They're put it into third normal form. So this is just like the lecture. It's just a flat table, one table, that you're going to pull out into 3 or 4. There's no set number actually, because there's a couple different ways of doing it actually. There's a couple right answers to this one. So it's a nice little brain exercise. If I were you, I'd pull it all out, put it in at, pull all this, cut and paste to put it into a text file, put it in a straight line, and then write your table. Do it like the lecture. Make first iteration, second iteration, third iteration. So go to first normal form, second normal form, third normal form if you wanted to. And then at the end, what you're just giving me is the end result. I don't need to know all of the different translations you went through. Just give me the final list of tables. Give me 2 items for each one of the tables. Give me the functional description and give me the description, the simple table description. Excuse me, functional dependency. If you give me the functional dependency, part of the exercise is to review the dependencies. You might be able to catch your partial and your transitive dependencies using the functional dependencies. And then just do it for your 4 or 5 or 6 or 12 or 15. No, you're not going to have that many tables that come out of here. So you could do it in more or less tables depending upon how you do it. Depends on how you think in terms of your logic. Because I didn't ask you to do it in BCNF. There's no BCNF on here. If you want to take it a step further, this lends itself to a BCNF solution, but I'm not asking you for it. I just asking you for third normal form. So you could have third normal form with BCNF, or you can have third normal form without BCNF. It's going to give you an extra table. That's how that's going to work. Questions on the assignment number 5, which is the last assignment that's due outside of the CSLO essay. No, I think it's time for lunch then. So let me stop the video. What time do we want to come back?